look at in a very quick way the potential difference and resistance. This is part of the topic we treated last time, that the current through a component depends on both the resistance R of the component and the potential difference across the component. So for us to be able to measure the potential difference across components, we must first of all understand how to connect that in this arrangement. Okay, so we are going to constructively define and explain how this diagram works. Okay, potential difference and resistance, how to measure the resistance of a lamp and find its potential difference. Potential difference is work done across two terminals or 2 points. All right, it's also known as the voltage and it's measured in volts. So we are going to look at the current through a component depends on both the resistance R of the component and the potential difference PD across the component. I repeat, the component flowing through the current, not component, the current through a component depends on 2 factors, and these factors are resistance R of the component and the potential difference across the component. Once again, I repeat, the current through a component depends on both the resistance R and the potential difference PD across the components. So, and that is exactly what this diagram you're looking at illustrates. Okay, illustrates how the resistance and potential difference across certain components can be measured. All right, so without wasting time, we begin by analyzing the schematic representation of the measurement of potential difference and resistance. So how do we do that? It is very simple. To measure the potential difference across a component, the component in question here is this. All right, the lamp or the filament. That is the component that is about to be measured, whose potential difference across this terminals. Look at it, terminal A. All right, terminal A is this. Let me write it well. Then this is terminal B. Okay, so we want to find that. So with this, we will know. Let me do it. Let me do it better. Oh, this can be okay. So what I'm trying to say, or rather what we are trying to do here, is that we are trying to estimate, we are trying to explain the topic we are okay. The topic we are going to discuss today is potential difference and the resistance. And this diagram is going to be used to explain how potential difference and the resistance in a given circuit can be analyzed. All right, having said that, the aim of today's class is for us to understand how potential difference across a component can be measured. And this is a schematic representation of how such measurements can be taken in a given circuit. All right, the current through this flowing through this circuit is dependent upon 2 factors, and these 2 factors are the resistance of the component to be measured and the potential difference across the component. I repeat, the current flowing as soon as the switch, this is the switch, as soon as the switch closes, current begins to flow through round the circuits. However, the current flowing into the lamp can also be measured. The potential difference, that's the amount of energy dropped between this point and this point, can also be measured. That is what the diagram is all about. And for us to be able to measure this and come up with something tangible, something concrete, we must first of all connect a voltmeter. Look at this, a voltmeter. All right, this illustrates the connection of a voltmeter between the terminals of the lamp, because we want to measure the potential difference across the component lamp. So if we do that, the voltmeter is connected in parallel. Look at it. It's connected in parallel with the lamp. That is what it means. That is the order. Okay? And this will help us to measure the potential drop across these two terminals. Call this point A, alright? Then we call this point B. Very, very interesting. Okay, so with that said, we should also know that potential difference is also known as the voltage. Yes, it's also known as the voltage, and it's measured in volts. Okay, whatever we have here, or whatever value we obtain between point A and point B, is measured in volts. So potential difference across two terminals is also referred to as voltage, and is measured in volts. Very, very important. That is the point 2. This point has been explained now. Okay, we have also explained this. For us to measure the potential difference across a component, the voltage, the potential difference can be measured by connecting a voltmeter in parallel with that component in order to measure the difference in energy from one side of the component to the other. All right, the key takeaway here, the key point or the key takeaway here is that potential difference of voltage is also a measure, look at it, is also a measure of energy per unit charge, is also a measure of energy per unit charge transferred between 2 points in a circuit. Very, very important. Very, very important. Therefore, a potential difference of 1 volt means that 1 joule of work is done per coulomb of charge. If we understand that, then we understand what potential difference is all about. If we understand that 1 volt means that 1 joule of work is done per coulomb of charge, then we have understood everything that has got to do with potential difference of voltage across a particular component. With that said, before we continue, I would like to use this privilege to ask you if you have found value in this. It is time for you to subscribe. All right? Tap the bell button for constant notification. Share to your numerous networks, to your friends, to your students. Who knows who you might be helping somewhere there. Do not forget to always hit the bell button for post notification. Each time a topic like this is uploaded, you will be among the first set of individuals that will be notified. My returning subscribers, my new subscribers, you guys are amazing. You're all welcome. Okay, thank you very much. All right, the next topic we're going to consider is energy, voltage, and charge. Because we have done this in our previous class, what we need to do now is to solve some mathematical concept here. But let me quickly recap what we did in our previous class here: energy, voltage, and charge. We have just finished discussing energy, potential difference and resistance. So energy, voltage, and charge through a potential difference. When a charge moves through a potential difference, electrical work is done and the energy is transferred. That has been said before. The potential difference can be calculated using this. Yes, the potential difference, can be calculated using this formula, all right? The potential difference can be calculated using this formula as we earlier pointed out, okay? Okay, right? Because we earlier said that potential difference is also known as voltage, and it is associated with energy, okay, and charge. So that's what we're trying to explain once again. Now, having said that, it is time for us to move on to the next slide and then do some calculation. All right, so question number 1, look at this. Question number 1, what is the potential difference PD? There should be PD here. What should be the potential difference PD for clarity purpose? All right, PD. All right, yes, what should be the potential difference, or what is the potential difference between 2 points if 2 coulombs of charge shifts 4 joules? That's what we're trying to say. So how do we solve this? Very simple. First of all, we write down our solution. Okay, we try to get our solution first. By the time we get our solution, everything falls into play. So our solution is, we write it down for clarity purpose so that we know when we are solving and what we are solving. Okay, this represents our solution. Now the next thing is for us to bring out what we're looking for. So we're looking for PD, okay, because that's the question. The first statement says, what is the potential difference PD between the 2 points? It means that PD is unknown. We don't know the value of PD in this question, right? So we're going to do justice to that. We're going to find PD. All right, so that's the first one. The second one is, we know that we have a charge. Charge is Q. All right, our Q, that's charge, is given as 2C, that is 2 coulombs. 2 coulombs, okay? 2C. Good. I want to write this charge very well. The Q is not resembling something meaningful, so let me rewrite Q so that it will resemble something meaningful, the letter Q. All right, so okay, now let's rewrite Q. All right, I think, yeah, this is better. So the value for Q is 2 coulombs, and then we have again shifts 4 joules. That's energy, right? We have E. Energy is E, right? Okay, so energy is E, which is given as 4 joules. Very good. For J represent joules. Good. So we can make use of this information to find the value of the potential difference. That's what it means. We can make use of this information to find the value of potential difference. Therefore, we should also know that PD, okay, P and D, meaning potential difference, is also represented by letter V. Let us not forget this. All right? Good. So if we know this, that's okay. Actually, that's the letter we are looking for. That's actually the letter we are looking for. So what we need to do, it implies that V, meaning the potential difference, is equal to, the formula now is energy over charge, okay? energy, E, all over Q representing charge. Good. So what do? We move on again and then substitute accordingly. Our substitution is going to be energy is 4, right? Let's write this 4 very well so that it looks good. Energy is 4, but our 4, I don't like the way the 4 is looking. So let's put it well, and then, yes, we have the value of energy according to the information we have is 4. Good, this is better. Then over, and the value of charge is just 2. Alright, good. So by the time 4 is divided by 2, we have what? 2. Good. It means that the potential difference across that component is just 2 volts. We need to write it in full to avoid confusion. It's just 2 volts. I think we have done something similar like this previously. Okay, this is just 2 volts. Alright, once again we need to rewrite that so that our viewers will understand what it means. We have something good here. We have found the answer here. Okay, so we have 2 volts. Good. So that's the answer. That is our answer. In summary, potential difference V is given as 2 volts. In summary, that's the value of the potential difference we're looking for, right? By the time we get this done, we'll be happy with ourselves. All right. Okay, 2 volts. So that is the answer. Solved. We have succeeded in solving this. So, if you have found pleasure in this, you have learned 1 or 2 things, you like what this is all about, learning, teaching physics, teaching science, teaching mathematics, teaching chemistry, biology, and so on and so forth. You like all this. Many more of this will come your way, but you need to do us a favor, subscribe. All right, subscribe, share to your friends, to your networks, to your students. Also click on likes, at least give us some thumbs up. Then the bell button for constant notification. Hit the bell button hard so that each time something like this is uploaded, you will be among the first set of individuals that will be notified. All right. Okay, let's see what we have. Next slide, we will look at question number 2. Question number 2 is going to be something very, very interesting and something we all will enjoy learning. So let's see how it goes. We are not going to waste time here. Our solution goes this way. Our solution is very simple. We just write in abbreviated form. Okay, solution dot. Good. All right, so what we need to do, let's just know what the question contains. How much energy is transferred when 3 columns, you see, when 3 columns of charge moves through a potential difference of 6 volts. So first of all, we want to find energy E. Okay, energy E is unknown at this point in time. Very, very nice. So we are looking for energy E. Watch out what we're doing. Energy is unknown. This question, energy is unknown. That's why we have 2 question marks. So next point. When 3 columns of charge, Q, the value of charge is known. Good. The value of charge is known and is given as 3 coulombs. right? Good. I want to write boldly so that my viewers can see my writing very well. Okay, so we have charge is given at 3 columns. Moves through a potential difference of 6 volts. V, potential difference, is given as 6 volts. Good. Let me write small v, 6 volts. Very nice. Therefore, our formula remains the same. We are going to recall that potential difference is given as V, E equal to E, right? Representing energy, all over Q representing charge. Okay? Let's do something better here. Representing charge. And that is another important topic, important aspect of this. We are going to represent charge here. Okay, Q. So we are looking for what? Energy. This is the one we are looking for. E. We are looking for E. So we can't use it this way. We can't use this formula this way. What we need to do is to make E, we have to make E the subject. Okay? We have to make E the subject of this formula and then substitute these values we have for us to arrive at the answer we're looking for, right? Good. So let's make E the subject at this point. E being the energy we are looking for from the equation given. Let's call this equation number 1. Let's call this equation number 1. Very, very interesting. Equation 1. From equation 1, we are going to derive or make E of the subject of the formula and then call it equation 2 and substitute accordingly. So E here is equal to, what happens here is that we have QV or VQ, right? V and Q. V and Q. Good. I want to write, let me write my V very well, properly, so that I want to erase this. Good. And then write it in such a way that whoever is watching will understand that this is V, right? Good. So we call this equation number 2. Good. This is equation number 2. So what do we need to do? Very simple. We are going to now substitute for Q and also substitute for V with their respective values and then simplify further to get the answer. So for V is 6. Right, we write 6. Good. Then for Q, multiplication sign comes in. For Q is 3. We write 3. Very simple, 3. And the next thing we need to do here is we multiply 6 times 3. Okay, we multiply 6 by 3, and what it gives us should be something 18. Good. 6 times 3 is 18. 18 watts. You ask yourself that question because every quantity has its own unit of measurements. Interesting, right? Good. So what we need to do, the unit of measurement of E, which is the parameter or quantity we are looking for, is joules. So we write it capital J. Okay, joules, J. I don't like the way it looks. It's very close to 18. I need to delete it. I need to erase it. Okay, I actually need to erase 6 and then write it properly so that there won't be any confusion in trying to read meaning into all these things. So this is my 6. Yeah, it's better now. And then joules, I shift my hand a bit and then write joules, capital J. Good. All right, my J, the leg of my J is looking somehow. Once again, I go back, pick my eraser once again, clean it. We need something good. And then go back again, pick my ball pen. All right, and then write in a way that makes meaning. Better. This is okay. Fantastic. Awesome. We have solved this question. How much energy is transferred when three columns of charge moves through a potential difference of 6 volts? The answer is 18 joules. The amount of energy that moves through, that's transferred when three charge of columns move through a potential difference, is 18 joules. Good. This is good. Correct. Done. So, do not forget to subscribe to this channel. Give us some thumbs up. Share to your friends. Share to your networks. Share to your students. Give us some thumbs up. Hit the bell button hard so that each time stuff like this, topics like this, questions like this are uploaded, you will be among the first set of individuals that will be notified. All right.